Welcome to the trading floor. I'm your strategist, and today we're stepping into an environment where split-second decisions absolutely dictate your final grade. Think of your exam like a high-stakes trading desk. You have limited time, immense pressure, and you have to know exactly where to invest your energy to get the maximum return on your marks. Okay, let's dive right into this. Today, we are targeting one of the most notoriously tricky, high-value areas of the Cambridge syllabuses. We're specifically focusing on 9626 information technology, but listen, this exact strategy is equally applicable and absolutely vital across the 0417, 0478, 2210, and 9618 computer science courses. We are zeroing in on topic 4.1. That means conditional branching, looping, nested loops, procedures, and subroutines. These are literally the fundamental building blocks of logical programming and algorithmic problem solving. And yet, surprisingly, they are exactly where most students just hemorrhage easy marks under exam pressure. Why does this happen? Well, because simply knowing the theory just isn't enough anymore. You need to know how to apply it systematically when the clock is ticking. By the end of our time together today, I am going to completely demystify these core concepts and hand you the exact blueprint that top-scoring candidates use to absolutely master this topic. To keep things perfectly clear and significantly lower your cognitive load, here is our exact flight path for today's session. We'll start by breaking down the challenge, then we'll move into the core domains and our specific processing sequence. After that, we'll tackle exactly how to deconstruct and solve problems, and we'll finish up with the ultimate safety net, method marks, before looking at some direct examiner warnings.
Section 1. The challenge. Applying abstract concepts to entirely new, unfamiliar contexts.
Let me ask you something. Have you ever stared at a completely blank past paper question involving a complex nested loop, or maybe a really tricky conditional branch, and felt your mind just go completely blank? The clock is loudly ticking, your palms are sweating, and suddenly you can't remember a thing. If that's happened to you, you are definitely not alone. It's the #1 roadblock. So, why do students find applying concepts to unfamiliar contexts so hard? You see, Cambridge doesn't just want to know if you can parrot back the textbook definition of a while loop or an if-then-else statement. Rote memorization of raw syntax is never, ever enough for top marks. Instead, the examiners will deliberately present you with a high-pressure, entirely unfamiliar scenario. It might be a complex data set for a hypothetical business you've never heard of, or maybe a convoluted hospital triage system process that desperately needs optimizing. Simply knowing what a subroutine is falls completely short when you're suddenly asked to evaluate its efficiency within a brand new context. The real challenge is making that massive leap from theoretical knowledge to practical on-the-spot application. It requires a fundamental shift in how you process information. Under the immense pressure of an exam,
Look, let's analyze two very common approaches that completely miss the mark. We see this all the time. First, we have Alex. Alex's strategy is basically to overload the answer sheet with raw computer science facts. Faced with a really complex question, Alex just throws down every single thing they've ever learned about procedures and conditional branches. They're aiming for superficial breadth, hoping something sticks, but they provide absolutely no deep contextual analysis. It's a massive data dump, not a targeted solution. Then, on the other hand, we have Sam. Now, Sam actually understands the underlying code logic, but Sam rushes the execution. In the sheer panic of the exam, Sam entirely misses the presentation conventions, forgets the proper terminology, and crucially, completely ignores the specific command words required by the question prompt. Both of these approaches lead to absolutely disastrous results and a page full of red ink. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving on to Section 2, Core Domains. We need to understand how your cognitive skills are actually being graded by the examiner. There is a massive, incredibly distinct divide between average scores and top-tier grades. Basic knowledge and understanding, things like just defining a loop or writing out basic syntax, that's the bare minimum. That is the floor, not the ceiling. The academic benchmarks for Cambridge prioritize analytical depth and logical, structured reasoning way over simply stating disconnected facts. They are explicitly looking to see higher-order application and analysis. This means you aren't just blindly writing a nested loop, you are evaluating the alternatives. You are actively decoding the specific command words in the prompt, comparing different coding approaches, and applying deep analytical reasoning to justify exactly why a specific procedure is the most efficient choice for that specific given context. A genuinely great way to structure this level of answer is through the PEAL framework. That stands for point, evidence, explanation, and link.
You make your point about the logic you're using, you provide evidence directly from the exam scenario, you thoroughly explain how the loop or conditional branch works, and finally, you link it directly back to the system's overall goal. If you want those top marks, your mindset has to transition right now from asking, "What is this?" to arguing, "Why is this the absolute best solution here?"
Section 3. The processing sequence. Establishing a strict, highly repeatable framework for your answers.
Whenever you are faced with a heavy, complex, branching, or looping question, you absolutely must rely on a systematic sequence to manage both your time and your logic. Don't just start writing. Step 1. Identify key elements. Extract the relevant variables, the exact constraints, and the data types from the specific scenario. Step 2. Apply relevant principles. Make a firm decision on whether this specific problem requires a conditional branch, a continuous loop, or a dedicated subroutine. Step 3. Execute the analysis with crystal clear, step-by-step working. Step 4. Verify the results. Ask yourself, does your logic actually hold up? Run a quick mental trace table right there in your head. And finally, Step 5, present the information in the correct format using strict coding conventions, proper headings, and exact terminology. Do not skip a single one of these steps. Following this exact sequence prevents that panicked data dumping we saw with Alex earlier and ensures you are capturing every single available mark. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's move into Section 4, Deconstruct and Solve. This is the interactive workshop phase of our strategy. Let's roll our sleeves up.
Let's walk through this critical problem-solving framework step by step. I call this the Deconstruct, Solve, Evaluate cycle. Now, imagine you are given a massive, intimidating block of convoluted system requirements under a very strict time limit. First, you need to identify the given information. You have to actively strip away all the narrative fluff and find the core data points that matter to the code. Second, break the abstract problem into logical, bite-sized steps. Look, don't try to write the whole nested loop all at once in your head. Write the inner loop first, test its exit condition, and only then build the outer loop around it. Third, solve it systematically, using clear, undeniable notation. Fourth, check for reasonableness. This is huge. If your loop is supposed to process exactly 10 patient records in a hospital array, but your logic actually runs an infinite loop because you forgot to increment the counter, you need to catch it right here before moving on. And fifth, make justified recommendations. This shows the examiners you aren't just some coding robot, you are an IT professional who can communicate complex logic using the correct terminology and professional formatting.
Section 5. Method marks. This right here is your ultimate psychological safety net in the exam hall.
Listen closely, because there is a direct, incredibly powerful warning pulled straight from the Cambridge Principal Examiner reports. They state, students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. I really want you to let that sink in. The process you use, your margin annotations, and your visible structured reasoning are just as critical as the final compiled result. If you attempt a really complex nested procedure and your final output is slightly flawed, maybe you messed up a greater than or equal to sign, but you have clearly annotated your conditional branches and shown the logical steps you took to get there, the examiner will absolutely award your method marks. Never, ever just scribble down a final answer and hope for the best. You must show your brain working on the page. Leave a trail of breadcrumbs for the examiner to give you points.
So how exactly do we maximize those method marks? We do it through evaluative thinking. This means you are constantly, actively identifying the limitations of your proposed code. You are relentlessly questioning the assumptions made in the prompt. You are offering alternative interpretations, or perhaps suggesting a completely different subroutine structure, and then you are justifying your final decision with solid, undeniable evidence. For instance, when you compare different approaches, say explicitly explaining why a for loop is vastly superior to a while loop for a specific set of known, fixed array data, you are demonstrating that higher-order evaluative thinking. This proves deep structural understanding and secures those crucial method marks, ensuring that even if one tiny technical detail slips your mind, your overall analytical depth is richly rewarded by the grader.
Section 6. Examiner warnings. Let's rapidly deconstruct the top explicit mistakes you need to avoid.
All right, there are 3 major, fatal mistakes you must avoid at all costs, and we've pulled these straight from the post-exam autopsies. Number 1. Forgetting to include proper format for branching and loops.
Indentation absolutely matters. Clear syntax matters. If your if then else statements are just a jumbled left-aligned mess, you will lose marks. Number 2, forgetting to check overall format and presentation. This is all about professional communication. You have to use the appropriate terminology and lay out your response clearly so the examiner can actually read it. And number 3, and this is the most common fatal flaw, answers that are not specific to the given context. Look, if the scenario on the paper is about a school database, your variables, your loop conditions, and your explanations better specifically reference students, grades, and classes. Do not use generic lazy terms like variable X and variable Y. Abandoning strict conventions and context specificity will cause you to completely hemorrhage easy marks. Under intense exam pressure, when the adrenaline is pumping, you need a simple, highly actionable memory hack. When the clock is ticking, panic can easily set in, and you need a way to instantly recall the 5 core components of Topic 4.1: conditional branching, looping, nested loops, procedures, subroutines. CLNPS. I want you to create a unique mnemonic right now using those first letters. For example, try this one. Code logic needs proper structure. Memorize that exact phrase. When you walk into that exam hall and open your paper, I want you to immediately write CLNPS at the top margin of the page. This simple act instantly grounds you. It builds immediate confidence, and it ensures you systematically consider every single necessary tool in your programming arsenal before you write even a single line of code.
Remember this: top candidates constantly evaluate evidence quality. They never just take the question at face value. So I leave you with this provocation. What hidden assumptions are lurking in your next past paper? What specific limitations are hiding in the scenario they've just handed you? Finding those hidden elements and properly analyzing them is the ultimate key to unlocking the absolute highest grades. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.